Okay, so how is everyone today? Good, I hope. Okay, so the first announcement is about the midterm announcement. So the midterm exam is going to be in class the Wednesday before spring break. And if I recall correctly, that is March the 7th. The midterm exam will have will consist of two sections. One section is going to be 3 or 4 cumulative exercises. So what I mean is that conceivably they could be over anything that we've done up to that point. And the next section will be, so of the approximately 20 WEXs graded out of 10, so of approximately those, you may select up to 10 to redo. Okay, so let's be clear about that. So when you come in and turn those in for homework, each of those is a WEX. So that's WEX 130, which is the 0th question from lecture 13, and WEX 131, which is the first question from lecture 13. And then you also take a quiz, and because we turned in 0 and 1, the quiz today is called 132, the question 2 from lecture 13. Of those, it's always going to be the case that just one of them is graded out of 10. Usually it's the quiz, but not every time. At any rate, whichever one was selected to be graded out of 10 is, in the first place, not announced in advance, so that you can't know which one am I going to do to the exclusion of the others. Also, I don't tell you in advance, but when the choice is made, it gets posted to the course webpage. So you know after the fact which ones were graded out of 10.
I'm sorry, tell me again where we find that. Where we see which one it was.
It's the part of the course webpage where you see the calendar. The calendar of events.
Okay.
So, of the approximately 20 WEXs that are graded out of 10 up to that time, you may select up to 10 to redo. So, what does that mean? So, it may be the case. I don't recall, but let's say, for sake of argument, that WEX 0092, which would be question 2 from lecture 9. Suppose WEX 092 was graded out of 10, and you did not do very well on that exercise. Suppose maybe you got a 2 out of 10 and you're not happy with that result on WEX 092. Then, after you've done these 3 or 4, however many I put in the mandatory section of the exam, after you do that, there'll be a little thing that says, okay, of the remaining questions, you can select up to 10, which means you could do 0 if you desired. You could also do 7, but you can do up to 10. There will be a question in the second section corresponding to WEX 092 that you didn't do so great on. You can redo it, it will be graded, and then you can have that grade. So it's a slightly double-edged sword. You need to be just a little bit careful, because what we're going to do is we're going to take whichever one you did last. So if it is the case that when you took WEX 092, you made 3 out of 10 and you didn't like that, and you do the redo on the exam and you make 9 out of 10, then, well, now you have 9 out of 10. But if you got 7 out of 10, and then you say, I don't like that, and you do a redo, and then you get 5 out of 10, now you have 5 out of 10. So the reason for this policy is that, well, 2 things. In the first place, I don't really care so much. I mean, I care a little bit, but I don't really care so much if you didn't know how to do WEX 092 exactly at the time that I asked. Okay, I understand. All that I really need to confirm is that you know how to do it by the time you leave college algebra. So we'll take the last measurement. So if you were to take WEX 092, you take the quiz in lecture like we do, and then you do it also on the exam. You have whichever one you made on the exam. Yes?
Are we going to have an indicator, like what our previous grades was for the exam?
Yeah, they'll all be posted. I think I've finally sorted out all the TA issues. They gave me like the greenest TAs possible. Like they just got picked from the TA garden, and they need a little bit of help getting everything all figured out. But I think I've got it now. Getting all the things graded and scanned, that got clogged up a little bit there, but now I think we've got that worked out. Yes?
So we're not doing exams on
No, I wish we were, because I'd rather not dedicate lecture time to that. But at any rate, I couldn't get what I wanted from the registrar. So we're going to do it during lecture.
Will the WEX questions be the exact same question as the one that was the other day, 13, 14, 2018? I mean, will they be the exact same?
Well, so they will not be identical. But many of the, as for the redo questions, the redo versions, many of them will just be, I just take the same exercise and change up the numbers. Some of them will be a little bit different, but at any rate, all of them will be, in my opinion, commensurate. Yeah, that's a good word. Which is to say that if you do a redo exercise, then I have 2 measurements for questions that I consider to be interchangeable. Other questions? Yes?
So do we need to just remember which ones we want to redo?
No. For this part, you can bring... No, I mean, that would be silly, in my opinion. So bring a sheet. Not a cheat sheet. Nothing is allowed. We're not doing any cheat sheets. But bring a sheet which contains your list. And it can contain nothing else except the list of questions. So it should look like, WEX 092, WEX 031, whatever it comes out. Yes?
So all the grades for everything will be posted by the time.
Mm-hmm.
Will they be scanned, available to see how we see
Yes.
where we messed up?
Yeah. And I'll post keys too, so that you can compare and contrast.
And my last question is, is there any review process or any guidance and preparation? I understand that, it's over everything we've done, but
Mhm.
sometimes there's some either review or
So I think I understand. So, well, as for the redo part, well, you'll have scans and keys of everything. So, and as for the rest of it, there'll be lecture notes, videos. It's all been posted, so I hold that to be enough. So the mandatory part is just cumulative, and different instructors have different opinions, but at any rate, I don't want to give you any specific or special preparation for the cumulative part, because that's the part where I determine whether or not you can synthesize all the things that you've learned. Put all of them together. Yes?
So our exam grade is just those 3 questions.
No, not exactly. So in the class, there are 3 graded items, and one of those 3 is really broken down into 2 categories. One of the graded items is the online homework, and if I recall correctly from the syllabus, that's worth 20%, I think. Another graded item, pardon me, is your attendance and participation in the class. So I calculate your attendance and participation by whether or not you did the online homework, and also how many of the WEXs you attempt. So that's your attendance, and if I recall correctly, I think that's 10%. So far we've spoken for 30%. The balance of your grade is WEXs. So the WEXs, there's 2 kinds. There's the ones that are graded out of 10, and then there's the ones that are graded on completion. So we turn in approximately 2 WEXs per lecture, and there's 44 lectures or so. So then there's between 80 and 90 there's between 80 and 90 completion WEXs per semester. They're each checked to make sure that you made a legitimate attempt, and they're out of 1. So if you turn in something and it's just blank, you get a 0 for that. Fine. So then, of those 80 or 90, suppose that we turn in exactly 80. We'll drop the lowest 8, the lowest 10%, because everybody forgets to bring their homework one time or whatever. Fine. So then we have the out of 10, pardon me, WEXs. We won't drop any of the out of 10s because you're given so many chances to redo them. So what I'm saying is that these 3 or 4 represent 3 or 4 out of 10, and then you can redo up to 10 out of the 20 or so out of 10s that have occurred since then. And then your WEX, then I'll average it up. It may be the case that by the end of the semester, considering all of the completion WEXs and all of the out of 10 WEXs, you were able, maybe there's going to be like 635 points. Well, then that 70% of your grade will be whatever percentage you got out of those 635. Was there a question back here? Yes?
So what do you mean out of 10? Like, because each of the lessons are like 2 problems each, right?
Mm-hmm.
So what do you mean when you're talking about out of 10?
Each individual page that you turn in, like for example, that one and that one. Suppose it is the case that we grade 130 out of 10. Then that page is worth up to 10 points. If it's graded on completion, then that page is worth up to 1 point. Other questions? Yes?
For the first part of the exam, will it just be, as far as answering the questions, can we just execute, or do we have to do the tedious, no offense, but
No offense taken.
The steps, all the steps with...
It'll depend on the instructions. Right, so if it says something like, for example, we had an exercise where it was more or less 2 polynomials were given, and it said multiply out these 2 polynomials, showing every distribution commutation, showing every distribution and commutation. If there is if one of these mandatory ones is that, then you must do that. But if it doesn't say that, then you're free to use more expedient techniques.
I have a follow-up question.
Uh-huh.
Again, no offense, but will there be a point in the class where we take the training wheels off and we can actually just, I mean, you're a great teacher, but there's just other ways that, you know, I've learned so many other ways of doing some of the things that we do, and so I kind of incorporate what you teach, and, well, I
In the
build
end,
on what I've already learned.
the answer
with
to your
what you're
question is
teaching.
yes and no. The answer to your question is yes, in the sense that we have already multiplied out some polynomials where you weren't required to show every distribution and commutation. So in that sense, the answer is yes. In the other sense, the answer is no, and the reason has to do with the fact that I've taught this course for so long. And well, here's the fact of the matter: is that the population of students who take college algebra usually do not have a very good estimate of their skills in math. And in fact, much of the time, students, it's just very rarely accurate. What I'll say is this, is many students overestimate their skill. And maybe like a third, but also 2/3 also underestimate their skill. So I don't consider students to be an accurate measure of whether or not they're skilled. As a result, I always ask for you to show all of your work, even tediously so, for two reasons. One reason is because I need to confirm that you know how to do it, and the second reason, I need you to be able to tell for yourself whether or not you know how to do it. I read from your face you don't really like my answer, but that's
No,
that's the answer.
I've just kind of had this confusion so far of, is it not okay for me to do things, because I can arrive at the correct answer, but I feel like I'm always having to make sure that I do
so
it
I'll
exactly how
stop you
say.
there, and that's the thing, is that that phrase, I arrive at the correct answer, that is not relevant. The reason why that's not relevant is because what's being graded in this class is the work. And so, you know, it may be the case that we have some story, and in the end, the answer is that there should be 42 apples. It's entirely conceivable we could go there, and that's great that there's 42 apples. But that's not what's being graded. What's being graded is you clearly demonstrating all of the intermediate steps from beginning to end. And that's it's just a stark difference that university students have to come to terms with. That's just not the way it's done in high school. Very often in high school, if the answer is 42 apples, if anywhere on the page you write the number 42, then you get full credit. And this is just not the case.
That's not what I mean. What I mean is, like, I'm writing out the steps of what I'm doing, but it may not be in a way that, for example, with factoring.
You have to factor it the way I demonstrate.
Okay. Can I finish the question now?
Please ask me after class, because we need to get moving. But in the end, you just have to do it the way it's demonstrated in class. Yes, was there a question over here?
So when you bring your list of like
Uh-huh.
the questions
Mhm.
that you want to redo, will those questions be on the exam?
Yeah.
Oh, okay. So you don't have to like write out the question. Like
No. It should just be just a name, like
Oh,
WEX
Yeah.
031. Yeah. Okay. So, we're talking about, what are we talking about? I forgot. We're talking about lines. Okay, a line is the graph of an equation of the form a multiply x plus b multiply y equals c, where A and B are not both 0. And to understand that qualification, that means that it's fine if A is 0, but in such a case, B cannot be 0, and vice versa. So notably, a graph, the math definition of a graph is that a graph is a set. So notably, we haven't said anything about the appearance of a line yet, like what it might look like. What is the name for a picture of a graph? A plot. So the plot of a line is flat. So you need to be careful when you hear a mathematician say flat, because mathematicians have a very specific meaning of the word flat that's not necessarily the same meaning as it is out on the street. So in particular, out on the street, very often the words flat and horizontal are synonyms, but that's not the case in math. So the usage in math and physics is that, for example, the floor is flat and the wall is flat. The floor is horizontal. Is the wall horizontal? It is not. The wall is vertical. And here's another surface that is flat, but when I hold it like that, it's flat, but is it horizontal? No. Is it vertical? No. So the plot of a line is flat. So now we kind of already, so we said flat, we said horizontal and vertical, and we're going to run with those concepts and assume that they're already known. Lines which are neither vertical nor horizontal are said to be sloped. So this is a comment about slope. The first thing is that the slope of a vertical line is undefined. So, for example, here's a vertical line. Suppose that we take a measurement, and that point right there turns out to be the point, say, 3, 1. 3, 1. Then what might this point be here?
3 something.
3 something, right? So how about, just for sake of definiteness, 3, 4? Notice that the horizontal coordinates are both 3. They're both 3. In fact, no matter which point you select on this line, what's going to be the x coordinate? 3 for every single one. As a result, the equation of this line, this particular line, is x equals 3. It's the set of all points whose x coordinate is 3. So here the slope is undefined. Okay. 2. The slope of a non-vertical line is m where you find m by doing the following procedure. So select two different points x1, y1 and x2, y2. I have to say different because I need to make it clear that you're not allowed to select the same point twice. So 2.2 will calculate delta x. Well, what's the formula for delta x? x2 minus x1. Because, well, delta x is the difference in the x's. And to be really clear, sometimes you can say the signed difference in the x's. What is delta y then? Well, would it be okay for me to write this? y1 minus y2. Why not? That's the difference in the y's. Ah, right. So then, right, is that it's perfectly fine to do y1 minus y2 if you also do x1 minus x2. That's fine. You just have to do these both in the same order. Then 2.3, m is delta y divided by delta x. As a picture, so suppose we have a line. We are told to select two different points. Suppose this is the point x1, y1, and this the point x2, y2. Then where in this picture is delta x? Where are you supposed to draw it? Okay, good. So you kind of make this nice triangle here. And then delta x is that measurement right there. And then where does delta y fit? Good, the vertical one. Okay, then the slope is the ratio of those two things. Now the colloquial name for delta x is run. And what's the counterpart of that for delta y? The rise. And as a result, you know, it is frequently said that slope is rise over run. Now, I'd like for you to observe that in case 2, because we're considering a non-vertical line, that means that the 2 points that we select are not on top of each other. They're not vertically aligned. As a result, what can we conclude about delta x? It can't be 0. So the non-vertical case, delta x is not 0. What about the vertical case? It's not just that it could be. It is 0. It must be. Because otherwise it wouldn't be vertical, right? So these two cases are distinguished by delta x. The vertical case is the case when delta x is 0, and the non-vertical case is when delta x is not 0. Any question about these things?
What's the application of that, of differentiating them? Like, is that something just to know in your head? Like, is that?
Well, the looking ahead, the place where it comes up most strongly is that we'll begin soonish talking about things called functions. And a line that is not vertical is a function. A line that is vertical is not a function. But that's some way in the future. Okay, so for example, so here's 2 points. And so I've plotted a line. 2 requests are going to be made. So the first request is find the slope of this line by finding 2 points, so finding the coordinates of 2 points, and of course I mean 2 different points. And using these to calculate slope. Okay. So reading that, I'll give you a second to catch up. So more or less what I'm asking is that I really highlighted 2 obvious, points that are on there. I want you to read the coordinates of those 2 points. Okay, so what are the coordinates of one of the points? Okay, almost. -4 what?
1.
-1. Right. Why -1? Because it's below the origin. What's the other point? 3, 2. Okay. Then, so it says do something by, and then it says specifically how I want you to do it. So we found the coordinates of 2 points, and we're going to use these 2 points to calculate the slope. Okay, so now, because we read 2 points from it, now we can literally just ignore the plot. It's not even relevant anymore. And we need to calculate delta x and delta y. So delta x is equal to, I'm going to do -4 minus 3. So is that okay? If you worked ahead, you might have done it differently. Is it okay for me to do it this way? Yes, it is. And delta y would be what? -1 minus 2, which is -3. So what I meant when I said you might have done it the other way is, well, I did this first x minus that second x. And then I did this first y minus that second y. And that's fine, as long as you always do, as long as the subtractions are in agreement. Same order. As a result, what is the slope? 3 over 7. So negative 3 over negative 7, and then the negatives cancel, 3 over 7. The most common error that I see students do is that they write 7 over 3. And my hypothesis, my guess, conjecture for why that might be the case is because when you calculate these two, you calculate delta x first, and it's very often above the value for delta y, and then it just gets copied that way. Yes?
To avoid that, is it okay if I like write delta y over delta x and then
Oh yeah, that'd be fine.
I don't have to like
No. You don't have to write everything in the exact same position that I write. Nothing weird like that. I just need to see all of the individual steps. I'm sorry. Could y'all's whispering is distracting me. Could you please stop? Thank you. Any question about this one? Okay, so now ignoring part 1, I'll say find the slope of the line by counting on the plot. So that's a little bit mysterious, so let me clearly demonstrate what it is that's being requested. So on the plot, I want you to do some kind of counting thing. So what I mean is that, well, start at one point, and I want you to count how many positions would you have to move to the horizontally to get to the other point. So 1, 2, 3, 4, 5, 6, 7. So to the right, we moved 7. So what does that tell us? What is positive 7? Delta x is positive 7. If we had started at this point and counted to the left, then we would have that delta x is what? Negative 7. Because the horizontal orientation is to the right. So if you find yourself counting to the left, that means you're counting negatively. Okay, from here, what do we need to do? Now we need to proceed in the vertical direction. So 1, 2, 3. So what does that tell us? Delta y is 3. Now why do we know it's 3 and not negative 3? Because it's in agreement with the sense of the axis, right? The orientation of the y-axis is up. And because we were moving up and we moved 3 positions, that means positive 3. If we were moving down, that would mean negative 3. Is there any question how we looked at the plot and did this counting thing to find delta x and delta y?
My one question is, so if we are asked to do this, we should start from the line and go towards the right angle of the triangle. Start on the line and count.
Right. So you start on one of the points and go the other way. It would have been just fine for you to start at this one and say 1, 2, 3, 4, 5, 6, 7, but then note, but I was going to the left. So delta x is negative 7. And then from here, 1, 2, 3, down, and that'd be fine too. Mm-hmm.
Then delta y would be negative 7. You could cancel.
That's right. Yeah. That's a visual manifestation of it doesn't matter what order you subtract these in, so long as you subtract them in the same order. And it doesn't matter what point you start from, as long as you end at the other point. So that's a visual manifestation of that same rule. As a result, we're able to conclude that delta x is 7, delta y is 3, and the slope m is 3 over 7. Of course, it's the same result as above. Now, in case it's not clear, I will state that you must draw the blah, 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 blah thing to get credit. The reason is because if you don't draw that, then it's not clear to me at all how you did it. Now, I don't mean to say that something weird like you've just got to make the points go up and the round part down. You know, nothing so weird as that. What I'm saying is that it has to be clear to the grader that you were looking at the plot and you counted something. And notably, I can't grade what's in your head. Any questions? Yes?
Instead of using the delta, is it okay to do x1, x2 for labeling?
I'm not sure I understand what you mean.
Like with the first, when you -4 and -1, to label -4 as x1 and -1 as y1.
Oh, yeah, yeah. Mm-hmm. But I do want to see the delta x's and delta y's.
Oh, so we do have to write delta x.
Right.
And do x2.
Right.
Okay.
Other questions? Good. So, now we want to figure out how to find equations of lines. So, we'll break it again into two possibilities. We'll say given 2 points on a line, given 2 points on a line, x1, y1, and x2, y2, we'll calculate delta x and delta y. So the first possibility that we'll address is that delta x is 0. So what does that mean about this line? It's vertical. So an example of this would be if we had the points, say, 5.29 and 3.7 is the first point, and 5.29 and 74.6. Now that's a little scary because all the decimals, but really, actually, this is not a big deal. Why not? It's vertical, right? It's vertical because the two x-coordinates are the same. Delta x is 5.29 minus 5.29, which is, of course, 0. As a result, that means that this line looks something like the following. It's this, like so, and how far to the right are we? 5.29. So its equation is just that, x equal 5.29. Any question about the vertical case? The alternative to delta x being 0 is that delta x isn't 0. Whoa. That delta x isn't 0, and as a result, this line must be sloped. In this case, it will look like so. Sorry, I'm kind of rushing because I'm up against the clock here. So we have 2 points, x1, y1, and another point, x2, y2, but I won't bother drawing the other point because delta x isn't 0. We're able to establish that the slope is m equal to delta y divided by delta x. So if we find any other point that's on the line, and this particular point is mobile, it can be moved around. M-O-B-L-E, is that how you spell mobile? I-L-E. Yeah, mobile, right? Mobile. This point is just xy. Because we know the slope of this line is m, it must be the case that y minus y1 is equal to x minus, divided by x minus x1 is m for all points x, y. And we can take this equation and I'll multiply both sides by the denominator of the left-hand side to obtain y minus y1 is equal to m multiplied by x minus x1. And this is the equation of a line through point x1, y1 with slope m. And this is an equation that is assumed knowledge from now on. It is rather uncreatively named the point slope equation. Okay, and that's all the time that we have for today, so now let's have a quiz.